All right, welcome to this lesson with Teacher Kamanga in physics. Now, today we want to look at wave, properties of waves. So we have this question that is extracted from GC 2019 Science Paper 1. So we have question 5. Okay, so the question is saying figure B 5.1 is a graph of how a wave is propagated. So this is what we are seeing. This is a graph of how the wave is propagated, as we are seeing there. Okay, this side we have the distance and this side we have the displacement, so we need to understand in those terms. Very important. Okay, so now our first question is saying from the graph determine the amplitude of the wave. From the graph determine the amplitude of the wave. So what we need to understand is that the amplitude, it is the maximum displacement of a wave from its resting position. If you can see properly, the resting position of the wave is that in that line that we are able to see. So the maximum displacement is from here up to there. Okay, so that is where the maximum displacement of the wave. So for us to be able to determine the amplitude of the wave, we just need to locate the number, looking at the peak of the wave just there. So there we're able to see that we have a 15 there. We have a 15 meters there. So the 15 meters qualifies to be the amplitude of the wave. So here our answer is 15 meters. Okay, I think everyone there, it was discovered with easy. So let's just make sure that we can still refer to the hard copy of the paper if you have, or you can still download this paper so that you should be able to see clearly, because my paper is not clearly as we can see. So like I've said, we have the 15 there, which is on the peak there. So that is going to be our answer. Okay. All right, let's come to the second one. We're saying from the graph determine the wavelength of the wave. From the graph determine the wavelength of the wave. So we understand the wavelength of the wave in this case can be determined from one crest to the next. So from one crest to the next, so from here to there, that is one wavelength, or from here to there, that is also one wavelength. So we need to understand this distance. Okay, so for us to be able to determine that, it's very simple. What we're going to look at, we follow the line like that, and also we follow the line like that. So if we follow it straight, we follow it just straight nicely, we are arriving at this side, we are arriving at 75. Then when we follow it nicely, this side we are arriving at 15. So for us to find the wavelength here, what we're just going to do, say 75 minus 15. So our answer, when we subtract, we're going to have 60 centimeters. Okay, so our answer is going to be 60 centimeters, like that. Okay, so this is very important to say. When you come down here, this is where you're going to determine the value, but your guide is going to be from one crest to the next. Okay, I hope we are clear on that one. Very important to understand. Okay, I hope we are following. All right, now let's try to come to the next one. We are saying the last one, calculate the frequency of the wave if it travels at 3 meters per second. If it travels at 3 meters per second, calculate the wavelength of the wave. So this is also very important that we understand how we're going to determine the wavelength of the wave, because what is there is that we have the formula where we're saying V is equals to F times the wavelength, which is the lambda, like that. Okay, so now since what we've been given in this case, we've been given that the speed is 3 meters per second. So the other thing that we need to understand is that when you're looking at the units, the SI units, here we have the centimeters. So these centimeters that we've already found, because we've already found the wavelength, which we are supposed to replace in our equation. So it is in centimeters. Therefore, we should be able to change that centimeter into meters so that it can be able to fit in our equation. So this one, we've already found that it is 60 centimeters. This is what we're going to change. So in changing this one to meters, what we just need to do, we just divide with 100. We know the conversion units, so are the ones that we're going to use. So our answer is going to be 0.6 meters. So the 0.6 meters is the one that we're going to replace in the formula. Okay, the 0.6 is the one that we're going to replace in the formula after converting it into meters. So we'll say V is equals to F, which is frequency, times wavelength. So what we have is V. Since here we are looking for the frequency, so we make f the subject of the formula by dividing both sides with the wavelength, even this side with the wavelength. Okay, so what we are going to have as our final equation that we are going to use in this case, we'll have the frequency is equals to V over frequency, like that. V over wavelength, like that. Okay, so what is very, very important is that we should be able to know how we're going to be manipulating the formula so that we are able to make f the subject of it. Is also very, very important. The idea of making f the subject of the formula is very important. We need to understand that, very, very important, so that it can fit in our equation. Okay, so let's come to the calculations now. So what we're going to do, we're going to say we have okay, so what is needed is just to make f the subject of the formula. F, which is the frequency, is equals to V over wavelength. Okay, so since we've already seen that we need to change, and we've changed, so it will be 3 over 0.6. So the answer is going to be 5, like we are saying. So the answer is going to be 5. That is going to be our answer in this case. So 5 is going to be our answer, 5 Hz. So what is important is that we should be able to know how we're going to be manipulating the formulas to change and make the desired function to be our subject of the formula. So in this case, we are changing to make f the subject of the formula. So it's very, very important that we understand. Okay, so this has been Teacher Kamanga with you on Waves. So I hope you have benefited from this lesson. Have a lovely day.